there's a few different changes coming in, a couple of things enhancing older tools and a couple of big flagship new tools that we'll go through. Some of the topics we're going to cover is auto dimension now supporting ordinate dimensions, mark verification now allowing iterative marking with alphabetical marks rather than numerical marks, the addition of the ticket sheet count parameter for title blocks, some changes to how we support Revit walls for assembly creation with brick finishes and things like that. And then some of the updates to project shared parameters to support hardware details, which is one of the two flagship features along with clone ticket. So that's going to kind of be the itinerary for what we're going to talk about, and I will run through these. You know, how to operate the tools, what to expect when you run them, and then if you guys take a look at the help files once we're off this call, there's going to be some additional context for exactly how those tools are going to do what I'm describing them doing. So let's jump right into it. So the first thing that I want to show is the dimension tool now supporting ordinate dimensions. This tool still works exactly how it did in the past. All of the operation steps are the same. But now, as some of y'all might have known, previously we were not allowing you to select any kind of running ordinate dimensions from this list in the ticket settings. Now you are able to. So in this case, we have this ticket running gap to element dimension style set up for auto dimension. And we're going to go ahead and use that here. And you will see that it's able to come through. Now, something to note is that due to technical limitations with Revit's dimensioning, these ordinate dimensions do not support upsetting in the same way that the other linear dimension styles support that. So you're going to see this text come in kind of squished together. You'll just have to drag that out to make it look like whatever you need it to look like. But this now will at least allow you to place those dimensions into your views as you see fit. Okay. So we'll just go ahead and switch off that. And I guess another thing to mention is that setting does also apply to our other ticket settings where you can choose dimension families or dimension styles. That applies to auto ticket, ticket auto dimension, e-drawing auto dimension. Clone ticket's a little different, but we'll get to that. And it also applies to hardware details. So moving on, the next thing that I'd like to show is the mark verification initial alphabetical naming. This is now a setting that we have added to the mark verification settings. Where right up top, you can choose what your incrementer will be. You can choose numerical for the legacy style where you set the minimum integer value to start from, or the new feature is alphabetical. Note that alphabetical is only going to allow you to start from A. We don't let you start in the middle of the alphabet. It's just always going to be from A up. And then I believe that after Z, we go to double letters. And then that is what's going to give you those marks past 26. So in this case, I've already set up my mark verification settings to have this alphabetical, but I'll go ahead and save it anyway. And you'll see that currently this model is marked numerically. So if we go in and we do our mark verification initial, you'll see that now it's decided to mark them alphabetically. And it's warning us about this because we've already assembled these pieces. Again, if you were trying to update a model that had previously been marked numerically with these alphabetical marks, you would need to go back in and recreate assemblies to make sure that the names match. But this is just something that you'll see here in the demo because of the way I've set up this model. Okay. And if we apply this, you'll see that the actual pieces are now marked that way. Okay. I'm going to go ahead and undo that because I've already set up my model a certain way, but I just wanted to go ahead and demonstrate that tool. Okay, fairly self-explanatory on that one. The next topic that I do want to mention is the TKT sheet count parameter we've added. That one's pretty much exactly what it says on the tin. Whenever you run the ticket populator or auto ticket generation or any of our other ticketing tools that create sheets, we will be writing to your sheet that you've just created, this TKT sheet count. This will reflect how many sheets you have for that piece, and that lets you do things on your title block like sheet, X of Y, being able to set up parameters for that so you're not having to hard code it every time. Again, this current title block that I'm using is not set up to use that parameter, but you could link it via a label just like any of our other ticket title block parameters. Okay. The next feature, or the next upgrade that I'd like to show to an existing feature is one that's going to be important if you were using the Revit wall workflow for any kind of brick finishes or any kind of similar finish pattern. In the past, the intended behavior was to only support adding brick walls whose names contained the term brick veneer. There was actually a bug in the code before release 11 causing that not to be the case, and it to basically add any Revit wall that happened to intersect the piece you were assembling. With the 11.0.0 release, this came to our attention because we had several users seeing walls not getting added to assemblies and strange unpredictable behaviors. So in the hotfix that just went out, we made an update to how this functionality works. And this is something that you're going to need to be aware of to update any existing models because it's going to affect what gets added to the assembly. So in this particular example, we have a wall panel assembly right here, and we have a Revit wall that intersects it. And this Revit wall that intersects it has a type name of finish demo. This type name could be anything that you wanted, including brick veneer. But regardless, if I ran the assembly creation tool right now, we are not going to see that get added to the assembly. Instead, in order to make it be visible to the assembly creation utility, you need to go into your Revit wall and you need to turn on this new shared parameter called isFinish. This is a shared parameter that will be added by the project shared parameters tool, which we're going to cover some of the other updates to that in a minute. But when you're setting up your project, if you have run project shared parameters, this will appear on all of your Revit walls. And if you want it to be included in assemblies as a finish in that way, you're going to need to check this box and apply it. And as you can see, once you've done that, when we run assembly creation, that brick pattern is now added to the assembly correctly. Okay. And that basically covers the updates to existing tools. As far as small quality of life changes, there are a handful of other bug fixes and performance changes and updates that go into this. Nothing that's worth going into right now, but a lot of it's just from customer feedback on things that were slow or were not working quite correctly. So those are the major ones. Now moving on, we're going to go into some of the new features that we've added, namely clone ticket and hardware detailing. These are our two flagship features for the 11.0 release. You may have already messed with them some with the release last month, but there have been some updates made with this hotfix, specifically affecting performance. With some of the new functionalities, assembly creation was negatively impacted in the 11.0.0 release as far as its performance. With this update, we've brought it more back in line with what it was before 11. And on top of that, with this hotfix, we fixed some performance issues with the clone ticket utility itself from 11.0.0. So the clone ticket utility's purpose is to let you take a completed assembly shop ticket and copy it out to other similar pieces while preserving all of your annotations, dimensions, and other features applied to that ticket. So here I've set up a shop ticket ahead of time. This was created purely using our auto ticket utility. And that's going to be important in a moment, and I will explain why. But this was set up using auto ticket. We brought in a couple of annotations onto this sheet just for demonstration purposes, some detail lines, a text note, an annotation symbol, and a legend from the project. As well as schedules and all of the other features that AutoTicket currently supports. So, the way that you operate the clone ticket tool is you are going to run the utility, select the assembly that you're copying from, and note that this will only list assemblies that currently have a ticket for them, because otherwise there would be nothing to copy. So in this case, we're copying from WPO1, and we're going to copy 2, 2, 3, 4, 5, and 6. Here, you're choosing the same things that you would when creating a ticket template. You're choosing BOM alignments, BOM stacking, all of this other stuff. You can configure it per sheet, or you can apply it to all using these buttons. But regardless of your settings, you can go ahead and click through, and the tool will run on these different sheets. Note that the performance will vary. It scales to the size of the model because it is fundamentally copying all of this different information. We've made big strides in speeding it up from where it was at the 11.0.0 release, but your mileage may vary depending on what model you're running it on. Okay, as you can see, it completed. It'll list out the ones that it copied to. I clicked the message, but you probably saw it for a moment there. And if there were any that had issues or any dimensions that couldn't be copied, or for whatever reason something was run into while the tool was trying to do what it was trying to do, it will warn you and it will list out the pieces with issues. In this case, everything worked fine because, again, we started from something very in the can, edge workflow, auto ticket style chop ticket. So looking now, we have our WPO1 that we copied from, so let's start looking at some of these others. And as we can see in the 3D view here, there's a few different key differences. There's a few key differences between these from location of windows, location of various elements within the piece, so on and so on. And this is our source here, our WPO1, and these are the ones we're copying to. So we can see here on the WPO2 that we've created something very similar. Our schedules come through. This is correctly templated out to WPO2. We've got our legend that we had here. We've got all our annotations. And we've also copied all of the dimensioning information and all of the callout information from the source. Obviously, we have not copied over dimensions for the lifting elements that are no longer present in this one. And we've adjusted the various dimensions to match the geometry of this piece. Moving on to just some of these other ones, we'll just kind of click through quickly. You'll also note that these plates here, these P361s, I believe they are. Yes, the P361s are in different locations between each of these. Should have zoomed in on that. We have an algorithm that attempts to match similar elements within the piece from the source to the target. If you want details on how that algorithm works, you can look at our help file. It's fairly involved, so I don't want to waste anybody's time with that right now. But ultimately, it's a process of checking to see locations, checking relative positions to the size of the piece, and making the program's best judgment call as to what matches the source. And as part of that, also, you will see in that documentation that there are certain times where we try to find things that are at the same location. And something to note here is that we actually have a settings configuration under ticket and dimension settings for clone ticket called same point tolerance. This is going to be the tolerance within which we search for things that are required to have the same location. Again, that's going to apply specifically to piece geometry. That's going to apply to situations where we can't make that best guess judgment call. But this is something that you will see in the help file, and if you're looking for where to configure that, it's right here in the ticket and dimension settings for clone ticket. Okay. And stepping through, I'm not going to harp too much on all these different ones because you'll see essentially the same behavior with all of them. This is obviously the one with the finish wall placed into it. I think my view template, yeah, here we go. There's the pattern showing up. Just go through the rest of these real quick. You can see here that we do support going to panels with significantly different dimensions for the piece, but do note that things like the callouts, as you can see here, are based on their position in the source. So there might be some strangeness that you'll have to clean up in those particular scenarios, but it should be more or less plug and play for anything that's similarly dimensioned. Okay. Another important thing to note for clone ticket as well, I'm not sure that there's a great way to show it with any of these pieces in particular. But something to note with clone ticket is that if you have an element that is not in the source, but is present in the target assembly that you're copying to, rather than ignoring elements in that target, and rather than trying to guess what you wanted to do with them, if that element did not exist in the source, we're just going to run the auto ticket algorithm for dimensioning and calling out so that you have something representing that element on your shop ticket. Again, that's all documented again in the help file if you want to look into how it's doing that in the future. But ultimately, that's the important thing to note. One other important thing to note with the clone ticket tool, and why I mentioned that if you're doing this from a shop ticket created using edge tools, things will be much simpler. When we copy dimensions to elements in the piece, we are only looking at dimensions pulled to edge dim lines for the elements in that piece. So it's very important that if you have people doing custom dimensions or doing any kind of work that's outside of that core edge workflow, make sure that you're pulling those dimensions to those built-in edge dim lines in the family if you want to see them cloned by this tool. That does not apply to the dimensions to the geometry in the piece, but it does apply to any kind of embeds, lifters, rebar, any of that kind of stuff. Okay. I believe that more or less covers everything with clone ticket. Again, the operation of the tool is meant to be as plug and play as possible. We're trying to make it as automated as we can without getting in y'all's way. But we're hoping that this saves a lot of time with trying to clean up tickets for similar things, and we're hoping that y'all get a lot of good use out of this. And if you have any questions or feedback or comments on it, feel free to leave them in the discussion here in this webinar, or email edge support with any questions that you might have. But that is the operation of the clone ticket tool. Okay. The other flagship tool for this release is the hardware detail tool. So the idea here is that rather than in the past, we've used some kinds of freeze drawing utilities or done freehand drawings of hardware details, or maybe done things in CAD and brought them into Revit. We're trying to find a way to make a model-based approach to hardware detailing. And that's the goal of this suite of hardware utilities. All of them are built around this hardware detail tool, but obviously we have some settings utilities, which I will go through in a minute to explain how all of that works. But the first thing that I need to discuss with hardware details is the changes that were made to the project shared parameters tool in order to make hardware details functional. So at its core, what the hardware detail utility is doing is it's taking a piece of hardware that you select, copying it out, and creating an assembly for which you can create sheets, views, anything that you would normally do with a piece ticket, except now it's for a hardware element. So importantly, we need to make sure that that copied out hardware that we use for this tool is not getting counted in schedules. We need to make sure it's not getting shown in views. We just need to make sure that it's kept completely in its own world and not interfering with your actual model behavior. To facilitate that, we made some updates to project shared parameters. The big ones are to do with schedule filters and view template filters. So what project shared parameters is going to do is it's going to add a filter. I'm going to pull up an example here so you can see what I'm talking about. We will just use, really any of these will work. We'll just pull this one up for now. It's going to go through every schedule that you have that does not have this hardware detail parameter set, and that is not set, it's null, there we go. Every one of these schedules that does not have this checked on, it's going to go into the filters, and it's going to add this filter that says the do not schedule does not equal yes. When the hardware detail utility creates those copied elements, when it creates all of the things that it creates, it's setting this do not schedule shared parameter to true on those elements. So by adding this to all of your existing schedules, we make sure that you're not pulling in any of that hardware detail material. Very, very important to note with these. There's actually two behaviors for how it's adding this schedule. And these are to play around the limitations of filter counts in Revit. So as I'm sure probably everybody on this call has seen at one time or another, you are limited to this number of filters in your schedule. If we try to add the do not schedule does not equal yes filter, and you're already at the cap, we're going to show you a warning saying, hey, you were at the cap on the filters. We did not add this. Make sure that you handle it some other way. Again, that's just purely a Revit limitation. There's not really any way around that, but it's something that you need to be aware of. The second behavior is that if we look at one of your template schedules for ticketing, so for example, the parts list template, and we look at the filters here, and I apologize, I didn't show myself running project shared parameters because I ran it when I set up the model. But you know what, I can do it real quick here. We'll just show you what I'm talking about. So you'll see this warning, and it's going to say, we could not add a do not schedule parameter to the Z parts list template. Now, if we actually go in and look at that, there is still space for one, but because of the way that the ticketing works, it needs to keep that space reserved for the construction product host filtering that allows bills of materials to work on shop tickets. So for these, specifically these ticketing schedule templates, we're going to cap at one under the Revit cap. This ensures that we keep one open for these copied out parts lists and similar. That is something that was not present in 11.0.0. So if you guys ran the project shared parameters utility on that release before the hotfix that just came out, you might have seen some strange behaviors when you tried to run auto ticket or the ticket populator, because it was filling up that last filter and blocking you from being able to add that construction product host one. Just make sure that you look back at any models that tool might have been run on in that specific release before this hotfix to make sure that everything's correct there. And we apologize for that mistake, but it's fixed now, and everything going forward should work correctly there. So that's what it does to schedules. The other thing that it's going to do, forgive me, I don't think I have a view template applied to its 3D, but let's just do model colors 50% transparent, it's fine. The other thing it's going to do though is in your VG override filters for your view templates, and specifically only for the view templates, we're not touching your visibility graphics overrides for views that are not templated, because we don't know what you might be doing with those. But for templates, we are going to add a filter for hardware underscore detail. And what that actually is doing is it's looking to see if the hardware detail yes, no parameter is turned on. And that exists for all of the categories that are relevant to hardware details. And if it's turned on, we're going to go in and we are going to add this filter and set its visibility to off. There are a couple exceptions to that. So if you had a view template that already had this hardware detail filter applied and you had explicitly set it to visible, we won't change that. And additionally, if you had a view template whose name begins with, just have an example in here, but if it begins with underscore HWD dash, those will also be left alone. And the reason for that is when you're setting up your hardware detail templates, you're probably going to need to set up view templates for those views it's going to create. And that allows you to say, these are going to be used for hardware details. We don't want to touch them. We don't want to add this filter to them at all. But every other view template in your project will have that update applied to it when you run project shared parameters. Additionally, obviously, project shared parameters will now add the relevant parameters for these tools, including the hardware detail parameter, including the do not schedule parameter, and so on, as with all of our releases. Okay, so that is the overview of what project shared parameters is doing to set up for hardware details. Now I'm going to run through the utilities that are associated with this tool, including the tool itself and the setups to get it where you want it to be. So first, I'm going to show you the final product by running the hardware detail tool on this piece of hardware. And I've already set up a template ahead of time, but I will walk you through how to create one as well in a moment. So in this case, we're just, this should look very familiar. It's basically the same window as the ticket populator, but we are looking at a different file for these hardware details. So there's not going to be any confusion of, seeing a ticket template listed with your hardware detail templates. It's all kept completely separate. So in this case, we'll go ahead and populate it. And you'll see, just like auto ticket, just like the ticket populator, we create an assembly, which I will show you here. We create an assembly that is named in a very specific way for hardware details with this underscore HWD dash. This ensures that it shows up at the top of your list of assemblies, keeping it separate from your pieces so you know what's what. And it will always be HWD dash, the control mark of the element that you selected for hardware detailing. And that's important to note because we only allow you to run this on elements that have a control mark set up. If it's not set up in that way, it'll warn you, it'll tell you what the problem is, and it'll ask you to run the tool once you fix that issue. But this will always be the naming scheme for the assembly itself. And as you can see, we've done something similar to auto ticket here. We've pulled dimensions to the piece. We've got overall dimensions showing the overall bounds of the element, and we've got individual dimensions to all of the raw consumables cooked into it. You will also see that we've populated a total weight and that we have populated child component weights. And I apologize, I set up my schedule wrong. This should be summing up the 1 pound there so that you actually see this equaling the same thing. But you have 4 of these 1 pound guys and 1 of these 5.1 pounds, creating a total weight of 9.1. So this is kind of the final product that you can expect. All of the features that exist with auto ticket more or less exist here. Having different kinds of annotation, copying them from other hardware details, doing any of those things that you would expect that to do, all of that can happen here as well. So let's back up for a minute and show how to operate some of the other tools involved in this. So first things first, and this is part of why I ran the original tool, because I want to cheat on showing you how to create a template. Normally, how you would do this is probably in a fresh model. You would take a piece of that hardware or any piece of hardware, set it up just like you would for your ticket templates, array it out with the template schedules, everything set up the way that you want it, and then create your hardware detail template from that. In this case, I'm going to start from a cleaned up version of this just for the sake of time, but I'm happy to, if you need to reach out and understand how to do the other process, I'm happy to answer that, or one of our support staff will help you with that. So let's just go ahead and clear this out. Okay. And now we've got something very basic here. And that's fine for our views. Just like with shop ticketing, you would arrange these out however you wanted them to be for your template creation. But there is another important thing to note. It's different with hardware detailing versus the auto ticket template process. And that's how we handle schedules. So you may have noticed that we did not create any kind of Z underscore hardware parts list template or any kind of ZZ SPX 007. That's because the way that these work is slightly different for hardware detailing. We're actually taking advantage of the assembly-based scheduling utility in Revit. I don't know if that's what it's actually called, but that's how I think of it. So if we go in here, you'll see that this is set up a certain way, but you'll notice that there's a view template applied to it. This is the only place in Edge where we use view templates for schedules, but it's very, very important for the hardware detail utility that you set up a view template for this schedule, because that is what's going to be written to your hardware detail template, and what's going to be copied out when you run this utility on your hardware. So it's important that when you create your hardware templates, because those are project agnostic, that you make sure any hardware detail view templates you've set up and applied to that hardware detail ticket template, that those view templates exist in all the models you're going to use this for. Excuse me. And something to note also is that if it does not exist, you will see a warning saying could not create the schedule, so on and so on. It'll tell you what you need to do But that is something very important to note, is that we need to have these view templates set up for the schedule or it will not function. So to set these up, it's exactly the same as if you were doing a regular schedule. All of these things, I'm not going to run through the actual features here because I'm sure you're all familiar with this. But ultimately, the way that you would create these, if you don't know this already, would be to set up the schedule the way you want it, go to view templates, and then create template from current view. That's how I would recommend doing it. In this case, I've already created the template, so I'm not going to mess with it, but that would be the process for creating the schedule view template. Okay, so with all of that set up, and again, this is a super simple version of this. There's all kinds of other things you could do. You know, you can configure your title block however you want, which we'll get to in a moment. But in this case, we're just going to keep it simple. Whenever you're ready, you would go ahead and do your hardware detail template manager. This is going to work the same way as the ticket template manager, except obviously, again, it's pointing at this hardware detail template file. And that is something that will be set up in your Edge preferences. I don't recall what the default is as far as the installers, but you can always look in here to see what that file name needs to be, and you shouldn't need to mess with it anyway. So once that's all good to go, whenever you create the template, it will save to that, just like your ticket templates would. So we'll just go ahead and make this. Again, just like with the ticket template manager, you're going to be asked how you want to do your bill of materials. In this case, I'm going to do independent because I have a place in a very specific location. And we can go ahead and create that and save and close. None of that should be unfamiliar. Okay. Now, the next thing that I want to run through, back to where I want to be. So the next thing I want to run through is these two files. Hardware detail, excuse me, let's do the hardware detail title block populator settings is more or less exactly the same as the ticket title block populator settings, except obviously there are much less hard-coded default behaviors being ported here. The important one being the combined hardware weight, which is going to basically be the sum of all weights within that hardware being written to this TKT HW weight. And once I finish going through these different tools, I am going to explain a little bit about how you need to set up your families to be compatible with this. But for now, just understand that the combined weight will be written to this TKT HW weight parameter on the sheet. And this is written every time that you run the hardware detail utility. You'll see that if you actually run the hardware detail utility on a hardware detail assembly that already has a sheet, you will have the option to just update title block values instead of fully recreating the entire sheet. And that would be how you would update this weight if you've made changes to that assembly. Other than that, it's the same process of source parameter is going to be any shared parameter you can access for those elements. Sheet parameter is going to be any sheet parameters that you can access as well. All very familiar. Lastly is the BOM settings. So this one's a little bit different because we don't have the same process of schedule template, schedule suffix. Instead, we only have setups for essentially the note schedules from the old ticket system. These are schedules that will be added from the model. Again, this is not using the same premise of the assembly schedules with a certain view template applied. This is pulling schedules from the model and placing them as notes on your hardware detail tool or on your hardware detail ticket. This is the same process as the ticket BOM settings when you don't have a prefix set up, but it is just different because those templates are not an option. So again, we'll just, because we did set up that template, we'll just run the tool again. And this is something to note. It will create so it's going to warn you, you're creating a hardware detail for something that already exists. because of how the hardware detail utility works and the fact that it's taking a snapshot of that element when you create the hardware detail, that is going to be important to note that it has to delete and recreate everything from scratch. So in this case, we're going to say yes, it'll delete what already exists, it'll delete the assembly, and it's going to create it from scratch. I believe demo manufacturer for webinar demo 2 is what we just created. We populate that, and you'll see that it creates it just like we expected. So again, not going to harp on that too much more. Those are the tools. That's how they function. A lot of it should be very familiar from how ticketing works. The one last thing that I want to point out, and you may have seen this earlier, is that under the ticket and dimension settings, we now have a tab for the hardware details. And in here, we have many of the same settings. In my case, I've configured a new callout family, overall style, general dimension style, and text style to fit the scale of the hardware detail stuff a little bit better than the ticketing version of those styles. But you're welcome to configure this however you like. And again, like we mentioned before, we now do support the ordinate dimensions if for whatever reason you want to include those on your hardware detail. Likewise, we have the same append string configuration settings and the same minimum dimension values as discussed in previous releases. So that's how the hardware detail tools work. That's how the setups work. I do want to talk real quickly again about how the family needs to be set up to work with these, because there are some very, very important notes to make about that. So let me go back to this SP007 family. So, and this is something that I've taken from a real family and kind of configured to work with hardware details for the purposes of this demo. But you'll notice that there are a few line styles in here that did not exist before. These all sort of operate under the same premise as the edge dim lines, but they are importantly not the same as edge dim lines. And the hardware detail tool will never pull to edge dim lines, because when you're doing these hardware details, you might be dimensioning to a different location on those elements, and it would not be prudent to go to edge dim lines for those. Instead, we have two new line styles, and the first one is not the one that's in this family. I'm going to show you in the subcomponent. The first one is this guy called HWD dim line. And what this is going to be used for is, as you saw back here, for these subcomponents, we need to pull to something. And that's what we are pulling to for the subcomponents of the overall hardware, for your raw consumables. So in this case, for the flat plate that I'm looking at, I have one of these pulled in the middle, which is what's creating the central reference on this dimension. And then I have some on the outside, which is creating the outer references. Although those will still be pulled to the overall as well, even if you don't have them on the outside. It's important to have them there in case you're doing something different with that. Likewise, you can see that I've put them at the center line of these straight bars that I've nested in here in that dimension. And I've put them laterally at the top so that you can see where those bars terminate below the plate. But at the end of the day, these are functioning exactly like the edge dim lines. It's going to pull your dimension references to wherever those are in the subcomponents of the piece of hardware. Now, importantly, those are not the only line style that we added. We have also added these little red ones. And these are the HWD bound lines. What these are going to do for you is these are going to serve as the, I'm just going to isolate those so you can see what I'm talking about. These are basically going to function as the bounds of your piece of hardware. And the reason that we need those is so that we can pull the outer overall dimensions. And that's what these are being pulled to right here, is to those little red HWD bound lines. Again, I understand that this is going to be a lot of setup work on the family to make it function with this tool. But this to us was the best way to allow you the flexibility to choose exactly how you want those dimensions to come out when you use this utility. And ideally, it's a one-time setup whenever you build this. whenever you build the family, to construct it in such a way that it's going to work correctly with this tool. Now, because these are new line styles, and this is something that you probably don't want to see in your hardware details, I would strongly recommend setting up your view template to hide them, just like with H&M lines. Same exact premise. Just going in here and unchecking these, making sure that they're not visible, so you're not seeing all of these lines hanging off of your hardware in your hardware detail. Again, you don't have to do that, but I would strongly recommend it if you're not wanting to see those. The other important thing to make sure that you set up when you're doing your families, if you want them to be compatible with the hardware detail utilities, is to make sure that you have a material set. The way that the tool functions for weight is it's going to look at your material configuration for those elements. Under the density field on the physical mechanical behaviors for that material, it's going to multiply that density by the volume of the actual element to generate your weights. If for whatever reason you don't have this material set, or you don't have a density set for that material, or some other part of this workflow is non-functional, if you have the weight per unit parameter added to the family, and I do not to this one, forgive me, but it is a shared parameter that's available in the shared parameter file provided with the installer. But if you have a weight per unit value set up, we will fall back to that instead of the material if the material is invalid. And that, again, will be multiplied by your volume to generate a weight for that part of the piece of hardware. And another important thing to note, I'm not sure if I mentioned this before, but if we actually go in here, you'll notice that we have two important parameters for the weight. So one is, of course, the TKT hardware weight, which we see down here being reported as the 9.1. But these subcomponent weights are actually being written per subcomponent in the piece of hardware. And importantly, it's only written to those subcomponents, to those raw materials going into that piece. The top level will not receive a value for this parameter for an important reason that I'll get to in a moment. And that parameter is, find it in here, HW component weight. This is what we recommend scheduling in your parts lists for the hardware details, because this is going to be how you get these subcomponent weights. You can sum them up. The reason that we don't write it to the top level is, one, we only want to write it to things that contain their own geometry. We don't propagate those up. So if you have an empty family with several things with geometry nested into it, the empty family will receive a 0 with the children receiving values. If, however, that top level has geometry, it will receive a value. So you're only receiving weights for the solids that are in that family level. Which is why the top level is not getting one here, because it doesn't have geometry. And the reason that we do it that way is that now, when you schedule this out, because the assembly schedules want to include everything in the assembly, you can easily set up a filter and say that you only want to schedule things where the hardware component weight is not 0. And that's going to easily filter out the top level from your list, because you don't want to see that. There's other ways to do that. You can kind of mess around with it however you want to implement that filter, but that's kind of what we've been doing in-house to prevent the top level of the hardware from being reported among the raw consumables going into it. So that was a very, very long-winded explanation of the family setups. But to recap, the important things there are to do the HWD bound lines and the HWD dim lines correctly, and to either set a material with a structural density or set a weight per unit for the subcomponents involved in that hardware. And as long as you set all of those things up, it should be compatible with the hardware detail tool. I believe that that's all I have for that. And that does include the new features and updated functionalities. So I guess if y'all, I'm not sure exactly how best to do this, but if we have questions in the chat, we can go ahead and start looking at those. So let's see. And I do have several people joining me here who might be able to answer some of these questions better than I do, but we will see what we got to do there. So first, answering Paul Arthur, is there a way to auto create welds in the hardware detail? There is not currently. Then let's see what we got here. Michael Simmons, adding another level of families, does that add weight to the model? So yes, the stuff, if I understand correctly the question, everything created for the hardware details will add weight to the model fundamentally, because it is legitimately a model element being placed in there. That is the goal of the do not schedule filter being added to all of your schedules, to avoid reporting those weights and reporting those materials from those elements that have that do not schedule flag set, which is something that the hardware detail tool will automatically set. Matthew Keck asks, can this steel card creator be used with company specific title block sheets? It looks like Taylor already answered that. But yes, that's correct. It's just like the other things. The title block is a family that should exist in your model that will be, you can pick from any of those in the drop down from the hardware detail utility, as you saw. That doesn't like that, so they're on view. Yeah, so you can either pick it here, or sorry, not here. Here, or you can set it up when you're creating the hardware detail template, and that will save to that template. But yes, it will save your setting for that. Okay, and then the other question that Matt Keck had was the naming scheme, and I'm assuming this was for hardware details. I apologize, I should have been looking as we were going through. Yes, so currently that can't be modified, and that's for the very simple reason of we don't want to accidentally start overwriting assemblies or creating naming conflicts within the hardware details that you're creating. So currently we're restricted to only be that specific naming scheme for the